All right. Let's look at another example here since you guys tried one on area. An open box with a square base is made up of 108 square inches of material. I want to make an open box, so it's open on the top. It's open on one side. It's going to be formed from 108 square inches of material. It's like I've got 108 square inches of cardboard. I want to make a box. What is the box that has the maximum value? What is the largest box that I can possibly make with an open top and 100 square inches of material? 108 square inches of material. Just like the print area question, I probably start by drawing a picture. Keep in mind, it's an open box, so the top, there's nothing there. It's like I can just drop something into it. It's an open box. Let's start labeling some dimensions. What do I know about the base of the box, the bottom of it? It's a square. Call this x and x. The length and width are both the same because it's a square base. We're talking about, let's just call this the height, or y if you want to, I suppose. We're trying to write or find the dimensions of the box that has a maximum volume. So our primary equation is going to be the volume in terms of x and h. In terms of x and h, what would the volume of this box be? Close. Close, not 2xh. You got to multiply everything together. X squared h. It's x times h. X times x is x squared. 2x is x plus x. But I like the idea. That's one right here. I've got my primary equation for the volume of V equals x squared h. I also have 108 square inches of material to make the box. So all the sides, the 4 lateral sides around the box, plus the one on bottom. Remember, there is no top. There's only 5 sides. Those 4 lateral sides and the bottom base have to have a combined area of the box. What's the area of the bottom of one of these sides? Just the bottom base is how much in terms of x or h. That's the perimeter, where I'm talking about area now. Area of the base would just be x times x again, wouldn't it? So it's x squared. If the box top, wouldn't it be x squared? Because it would be the same area on both top and bottom. I just got the bottom side, closed it. Okay. How about the 4 lateral sides, the front, the back, the left, and the right? They're all the same size. They have all the same area. All 4 lateral sides have what area in terms of x and h? Right. It's x times h because it's x times h for this side, but there's 4 different sides that have that same area. So 4xh. It's got to be 108. So we've got that checked off. Primary equation. We want to maximize the volume, so V equals x squared times h. We have a constraint. I only have 108 square inches of material to produce this box, so the total surface area of x squared plus 4xh has to be equal to 108. Question so far? Okay, once again, I've got to substitute this secondary equation into the primary equation. Volume, 108 square material. Do you want to solve for x or h? I think there's probably one that's going to be easier. Would it be easier to solve this secondary equation, this equation for either x or h? What made you say that, Caitlin? I agree.
Because you're only working with one variable.
Yeah, why solve for a variable when there's two variables that I have to work with, and I can only solve for a variable that has just one variable I have to work with? Solve for I need to x squared moved over. And divide by 4x. The height. And I will know that whatever box I have, the 100 square to be produced. The volume equals x squared times quantity 108 minus x squared divided by 4x. So multiply these together, maybe. Let's start simplifying here a little bit. 108x squared minus x to the fourth divided by 4x. I'll distribute that to the 102 on that. See, I could probably divide by 4x. What's 108 divided by 4? What's x squared divided by x? So let's start with a volume of 27x. Let's see here. I've got x to the fourth divided by 4x. So let's write that as 1/4. X to the fourth divided by x is x to the third. I'd much prefer to take the derivative of this volume function rather than what I had to start with. Here's a nice formula for the volume in terms of x. Give it 108 squares of material to produce the box to begin with. Find the derivative. What is it? What's the derivative of 27x? 27. What's the derivative of 1/4 x cubed? X. Set this equal to 0. Trying to find the box with maximum volume, so I want to figure out when the derivative equals 0. The maximum or minimum point, the derivative has to be 0. So let's get one term on a side. I'll add 3/4 x squared in order to do that. I chose to use the reciprocal because whenever I take a number, like 3/4 times its reciprocal, it's just equal to 1. So 1x squared. And bring down 4/3 of 27. What's a third of 27? Fine, so 4/3 would be 9 4 times. That's going to be 36. Works out nice. Because if x squared equals 36, that means that x has to be 6 inches. Yeah, is that right? Same perfect square I had from over there. I now know that the box has a 6x6 square base, 6-inch by 6-inch square base. What else do I need to know? The height. But don't I have an equation that gives the height in terms of x? The equation for the height in terms of x, right here. The height is equal to 108 minus x squared over 4x. And I now know that x needs to be 6 inches to make the largest box possible. Height equals 108 minus 6 squared divided by 4 times 6. We have a calculator here. That's 108 minus 36 divided by 24, which is 3. Not a very tall box. More wide than tall. Not a lot of depth. Got a 6 by 6